Yes, we're ready.
Okay, you can connect us to YouTube, Kurt.
Connected.
Good afternoon, colleagues, family, and friends of Professor Tricia Naicker. As we gather during this Youth Month, a time dedicated to celebrating the potential and accomplishments of young people, it gives me immense pleasure to extend a warm welcome to each and every one of you. My name is Professor Busingama. I'm the Deputy Vice Chancellor and Head of the College of Health Sciences. It is my distinct honor to welcome you to this special occasion, the inaugural lecture of my esteemed colleague, Professor Tricia Naicker, who is currently the youngest professor and director of the Catalysis and Peptide Research Unit. Professor Tricia Naicker is definitely the woman of first, as evidenced by her extensive CV. For an example, Professor Naicker made history as the first female editor-in-chief of the South African Journal of Chemistry, a journal that is over 100 years old. But you will have her bio read. Our Vice Chancellor and Principal, Professor Nana Poku, extends his sincere apologies for being unavailable today. He conveys his congratulations to Professor Tricia Naicker and his regards to Professor Naicker's well-wishers in attendance today. It is also worth noting that in 2019, Professor Naicker became the recipient of UKZN Vice Chancellor's Award, which is a special UKZN Vice Chancellor Award, which was in recognition of her work as a scholar. It's therefore my honor to welcome our esteemed guests, members of executive management, members of Senate, our inaugurant this afternoon, Professor Tricia Naicker, who we extend our heartiest congratulations to her on her achievement. Family, colleagues, friends, colleagues from the various universities and institutions in South Africa and in other parts of the world, our staff, our students and alumni, and distinguished guests, ladies and gentlemen. Today, we come together to recognize and celebrate the remarkable achievements of one of our own, a young professor who has made significant contributions to her field. Professor Naicker's dedication, passion, and innovative research have not only advanced our understanding in her area of expertise, but also inspired many within our academic community. As we commemorate the Youth Month, it is particularly fitting to highlight the achievements of young academics like Professor Naicker, who represents the future of our institution and the broader academic landscape. Her journey is a testament to what can be achieved with determination, hard work, and commitment to excellence. My appreciation once more for joining as she shares her insights and expertise with us. I look forward to Professor Naicker's presentation, which is titled The Symphony of Organic Chemistry, Chemical Synthesis. It is now my pleasure to hand over to my colleague, Professor Percy Mashige, who is the Dean and Head of School of Health Sciences, who will now introduce the Inaugural. Thank you.
Thank you very much, DVC, Professor Nama, and colleagues. I will read Professor Tricia Naicker's CV. Professor Naicker received her Masters of Science cum laude in 2008 and her PhD in 2011 from the University of KwaZulu-Natal, specializing in synthetic chemistry and novel tetrahydroisoquinoline-based organocatalysts. She completed her PhD under the expert guidance of Professor H.G. Kruger, G.E.M. Maguire, T. Govender, and P.I.A. Arvidsson. She then joined the research group of Professor Jorgensen at Aarhus University in Denmark as a postdoctoral fellow. Since August 2013, she has held academic positions at the University of KwaZulu-Natal, where she's currently the youngest professor and director of the Catalysis and Peptide Research Unit. Her research focuses on methods development in the synthesis of biologically important intermediates and drugs, particularly within the field of antibacterials. Professor Naicker was the first female editor-in-chief of the South African Journal of Chemistry and serves as the vice chair for the Organization for Women in Science for the Developing World, South African National Chapter. She is also a member of the South African Chemical Society. Professor Naicker's accolades include being inaugurated into the South African Young Academic of Science and African Academic of Science. Some of her esteemed institutional, national, and international awards include the 2017 Department of Science and Technology Women in Science Award, the 2018 National Research Foundation Excellence Award, the 2019 UKZN Vice Chancellor Award, the 2020 National Rakes Medal for the South African Chemical Society, and the 2022 Taylor and Francis John C. Warner Early Career Research Prize. Currently NRFY rated with over 100 publications, Prof. Naicker actively engaged in academic community activities, serving as an invited external examiner and a consistent peer reviewer for national and international journals, and participates in various academic committees. Prof. Naicker has been a guest speaker at numerous national and international conferences, including keynote addresses. With a robust network of collaborators, she has established formal linkages with esteemed universities. Besides her research interests, she is active in outreach activities, promoting science education and development at secondary and tertiary levels. Professor Naicker, congratulations. Thank you.
Thank you, Prof. Good afternoon to the executive management, colleagues, students, family, and friends. As an organic chemist working in Africa, I am honored, grateful, and humbled to deliver my inaugural lecture today. Organic chemistry is the study of carbon-containing compounds, which are the building blocks of life. It is a field that has transformed our understanding of the world around us, and it holds tremendous potential to enhance humanity. So what does a professor actually do? All day? Well, everyone seems to have a different idea. My family, my friends, my students, in my dreams. But what I actually do is this. And eventually it becomes everything that you see on this page, except being at the beach. Now, to be a professor, one must excel in 3 parts of this job. That is research, teaching, and academic service. For the purpose of this talk today and time constraints, I will only be able to talk to you about the research aspects. In order to explain to the non-chemists in the audience what is chemical synthesis, and ensure I don't lose you during this talk, I will start by explaining chemical synthesis. We all can relate to Panado. On a molecular level, the active ingredient in Panado looks like this. And we refer to this molecule in the lab as paracetamol or other chemical names. At the heart of organic chemistry is the idea that we can control properties of molecules by studying their structure and reactivity. We do this via chemical synthesis in a laboratory by putting reagents and chemicals together in a specific way to get the desired product. As chemists, we can create new materials, develop new drugs, and potentially solve a wide range of environmental and societal problems. Throughout this talk, I will refer to these 3 molecules and how it has shaped my career. That is the pentacycloundecane, known as PCU, the tetrahydroisoquinoline, referred to as TIC, and a pioneering beta-lactam chelator that we refer to in our labs as the BP series. These days in the South African academic landscape, one will come across these terms quite often, being asked as academics to promote these concepts. Now, I published my first paper in 2007 due to being surrounded by a team of forward-thinking individuals with a shared vision already 20 years ago that encompassed mentorship, collaboration, multidisciplinary research, and a commitment to promoting research for relevance. Towards the end of this talk, I will introduce you to this team. When both sides of such a relationship are committed to excellence, my career trajectory and story I will tell you today exemplifies the success that can result from such a model. Engaging with PCU or KH compounds provided me with a solid foundation in several advanced techniques fundamental to multi-step chemical synthesis. Bear in mind, chemical synthesis is not straightforward. It requires a laboratory equipped to set up, analyze, monitor, and interpret these reactions. And more often than not, the chemicals never behave as it appears in theory. Handling complex multi-step synthesis demanded proficiency in isolation and purification techniques, which I gained through extensive experience based on trial and error. The intricate nature of the PCU compounds necessitated the use of computational chemistry to predict the molecular interactions. I gained expertise in this technique to model and optimize these structures. The structural elucidation of the PCU compounds required interpretation of advanced NMR techniques. I became skilled at using these techniques to overcome the challenges posed by these complex signals of the cage. I developed and evaluated chiral PCU catalysts, focusing on high enantiomeric excess and selectivity. This introduced me to the world of asymmetric catalysis. Asymmetric catalysis is a method in chemistry that helps us create molecules in a specific orientation. Now, this is important because many biological molecules, like those in our bodies or in medicine, need to have a specific orientation in order to work correctly. By improving these methods, chemists can make drugs and other products more effectively with fewer unwanted side effects. This can lead to safer and more efficient healthcare, as well as benefiting various other industries. Now, beyond the expert knowledge that I gained from working with the CPU, I also acquired invaluable experience in teamwork, scientific writing, ethics, resilience, and handling scientific criticism. To the younger scientists in the audience, never be afraid of critics or someone pointing out your mistakes. This is where you will get the best shaping. Something very important I learned at this point was also that working in a team promoted validation of results, ensuring honesty and integrity behind every finding. This means collaborative efforts involve multiple perspectives and cross-checks, which significantly reduce the likelihood of errors or biased interpretations. These core principles are crucial to developing early in one's academic career and have been fundamental to my growth and success. The work on PCU, of course, resulted in several publications, as you will see here. The next molecular scaffold I will discuss is the tetrahydroisoquinoline. Now, remember I said I was in a team of forward thinkers. One of the most significant aspects of my experience with this team was their encouragement of professional growth and independence to all their students, not just me. They allowed me to pursue my own research projects under their guidance, providing resources and support during my PhD studies. This balance of support and independence was crucial in accelerating my development as a researcher. The group at the time was working on using these compounds as ligands for asymmetric catalysis, whereas my idea was to use it as an organocatalyst. After much hard work and perseverance, this eventually formed part of the first reports in this field coming from Africa. Engaging with the tick structures, I mastered the complicated process of multi-step synthesis, involving the sequential construction of complex molecules. This work focused heavily on enantioselective organocatalysis, where we developed and evaluated chiral catalysts to induce enantioselectivity in various reactions. This required a deep understanding of stereochemistry and the factors influencing catalytic efficiency. It introduced me to the field of organocatalysis, which is a method in chemistry that uses small organic molecules as catalysts to speed up chemical reactions. Developing new organocatalytic methods is important because it allows scientists to create more chemicals in a more efficient, safe, and sustainable way. These methods can reduce the need for expensive or harmful substances, making chemical processes greener and more cost-effective. This is crucial for producing medicines, materials, and many other products we rely on every day. Some other skills this project brought was learning to integrate advanced techniques, handle scientific rejection, and solve problems early in my career, which has been incredibly beneficial as an academic. These experiences not only equipped me with the essential expertise, but also built my resilience and adaptability, which is central for the success in the ever-evolving field of research and academia. By mastering these aspects early on, I was better prepared to face challenges and seize opportunities. This has significantly shaped my professional growth and achievements. This work resulted in several publications that afforded me the opportunity to pursue my postdoctoral studies with a world leader in the field of organocatalysis at Aarhus University in Denmark. When I first arrived in this lab, I was informed that I was the first African to be accepted here. Initially, this placed some pressure on me. However, I persisted in applying the skills that I'd been trained in. Before long, I was entrusted with the operation of their high-end instruments and invited to participate on numerous projects. During my time there, my work focused on exploring new chemical transformations using established organocatalysts. My postdoctoral experience was invaluable, offering me profound insight and enhancing my skills. It allowed me to recognize and uphold the rigorous standards set by the lab where I earned my PhD. This experience boosted my confidence and prepared me to effectively collaborate with chemists on a global scale. During this time, I encountered many aspects of research that I now become crucial in running my own lab. The guidance and mentorship from my postdoc supervisor, who remains a mentor and is listening here today, has been instrumental in my career. Apart from that, my postdoc was a really fun and exciting time, exposing me to new ideas, perspectives, and cultures. The connections I made there turned into valuable collaborations that continue to enrich my research. Here too, I was part of a bigger team. These were some publications from Aarhus and I encourage all emerging scholars to complete an international postdoc. When I returned to South Africa to start this current position as an experimental chemist, I faced some challenges. I had no funding, no fully equipped lab, and limited experience in teaching and academic service. To overcome these hurdles, I sought guidance from both my previous mentors and new ones in these 3 areas. Their willingness to support, collaborate, and share their resources was pivotal in kickstarting my academic endeavors. With regards to research, I wanted to apply all the expertise that I had gained in method development in chemical synthesis to make biologically relevant or medicinally important compounds. And I was quickly able to achieve that by working in a team. Just to give you some insight about my experience, working in a team allows you to discuss your ideas, which is not only vital for shaping those ideas, but it's also about finding the right plan to execute them. Remember, the 4th Industrial Revolution encourages us to collaborate purposefully rather than compete. So to tell you more about our team, everyone contributes their different and individual efforts to complete a project, be it their time, expertise, or funding. We operate without any strict seniority model, and everyone is free to pursue their research interests within the realm of drug discovery. Another unique aspect of our team is our diverse specializations and areas of interest. Each principal investigator has had different international exposure, bringing varied approaches and skills to the projects. Now, don't get me wrong. Working in an academic team doesn't guarantee success. You must actively play your role, which includes sharing ideas, defending your ideas, providing support, collaborating on research, securing funding, and continuously learning. Success in a team setting requires dedication, loyalty, open communication, and a willingness to work hard together towards common goals. For me, the biggest strength of teamwork is that it not only enhances the quality of research, but it upholds the rigorous standards to scientific inquiry. To the emerging researchers, if you want to engage in multidisciplinary research to make a tangible impact, ensuring your work addresses pressing societal needs, collaboration is key. It enables you to undertake larger projects, publish in higher impact journals, and secure larger grants. Working in a team allowed me to engage with multiple projects, still using my chemical expertise in chemical synthesis, but preventing me from getting stuck on a single endeavor. This collaborative environment helped me become more aware on when it was time to stop a project that wasn't yielding any results, allowing for more efficient use of my time and resources. As you will see, my work has been evidenced through several publications, awards, graduation of students, to which I don't have time to discuss all of them, but I would like to touch on just one project. Bedaquiline is the most critical pharmaceutical in the world, treating multi-drug resistant tuberculosis. It appears on the World Health Organization's list of essential medicines, and it is the only commercially available in a handful of countries. Despite it being highly effective, bedaquiline's chemical synthesis remains a challenge, thereby making it a very expensive drug. The problem is that its synthesis will lead to 4 isomers, which are distributed in a mixture of 2 pairs of diastereomers. But only one stereoisomer is most active against TB and is known as bedaquiline. This was the first report of a highly diastereoselective synthesis of bedaquiline under lithiation conditions with a chiral ligand. This method is receiving attention from international chemists around the world who have contacted us further to address the practical isolation of bedaquiline towards its larger scale synthesis. Since I work in a team with diverse expertise, the bedaquiline obtained from this study was further used to investigate its central nervous system penetration in an animal model using mass spectrometry imaging. This work is ongoing to further treat infections of TB in the brain and address other challenges with the isolation of Bedaquiline. On to my last molecule, that is the beta-lactam chelator. Here, I would like to start with a brief background. Antibiotic resistance occurs when bacteria changes in response to the use of antibiotics, thereby making these drugs less effective or ineffective. Basically, when you hear that prescribed antibiotics are not working, how it works is that bacteria can develop resistance through mutation or acquiring resistant genes from other bacteria. The misuse and overuse of antibiotics have accelerated this process. Antibiotic resistance is one of the biggest threats to global health, food, security, and development today. It can affect anyone of any age in any country. Resistant infections lead to longer hospital stays, higher medical costs, and increased mortality. Simple in-hospital procedures will become riskier without effective antibiotics. According to the World Health Organization, at least 700,000 people die each year due to drug-resistant diseases. By 2025, this number could rise to 10 million deaths annually if no action is taken. Of course, the economic impact is significant, with potential costs running into trillions of dollars globally due to prolonged illness and treatment expenses. Currently, there is a limited number of antibiotics in the world, since the pharmaceutical industry perceived antibiotic research and development in the past as a poor investment. Now that our primary defenses, the existing set of antibiotics, are fast depleted due to bacterial resistance, the world is in dire need of new medication. The emergence of resistance to beta-lactams, the most important class and last resort antibacterials, arises when bacteria produces enzymes called beta-lactamases that render the beta-lactam antibiotics ineffective. Inhibitors of lactamases have been used effectively in the past 3 decades. However, the bacteria now produce new types of beta-lactamases called carbapenemases. Carbapenemases can be divided into 2 groups according to their active site, as you will see here. Currently, there are no FDA-approved MBL inhibitors for therapeutic use, and there is an urgent call issued by the World Health Organization for new antimicrobial agents to address this critical gap. Our BP work focuses on the development of novel metallo-beta-lactamase inhibitors that has yielded excellent results to reverse the mechanism of this type of resistance, to ultimately restore the activity of existing antibiotic drugs. As you will see here, the BP chelator complexes zinc from the lactamase, which prevents the lactamase from cleaving the antibiotic, which is, this case, meropenem, thereby allowing the meropenem to be able to kill the bacteria. We are currently one of 3 groups in the world working on beta-lactam metallo-beta-lactamase inhibitors. Again, you will see multi-step chemical synthesis is the starting point of this project. This work is part of a much bigger project and involves experts from various fields that have assisted us in completing the preclinical evaluation of these compounds. This work has been patented, and I'm happy to report at the moment being licensed by a local pharmaceutical company and is poised for clinical trials. This project is a true multidisciplinary endeavor in the realm of drug discovery, requiring collaboration across various scientific domains. It pushed me out of my comfort zone, compelling me to expand my knowledge and integrate diverse scientific principles. Throughout the process, I not only deepened my understanding of drug discovery, but I also gained valuable experience in securing funding and managing a project with numerous experts. This journey underscored the profound impact that chemical synthesis can have on making transformative discoveries that potentially impact patient care and public health. Drug discovery is a complex and lengthy process. It typically spans 10 to 15 years, often with no guarantees of success. Since antibiotic resistance is such a serious problem, and I have a wide audience here today, I'd like to leave you with a take-home message on what you can do to prevent it. Only use antibiotics when prescribed by a healthcare professional. Do not take it if your doctor says it is not needed. Always complete the course of antibiotics, even if you feel better. Stopping the treatment early on can allow resistant bacteria to survive and multiply. Do not use leftover antibiotics or share them with others. Self-medication can lead to inappropriate use and increased resistance. Now, we all know this from COVID, to wash our hands regularly. However, please also practice safe handling of food and maintain cleanliness to reduce the spread of resistant bacteria. As I conclude today, I hope you've seen how organic chemical synthesis embodies a symphony of innovation and discovery. Throughout this journey, these three molecules have played a pivotal role in shaping my career. PCU provided me with foundational knowledge, TIC opened doors and doors of opportunity, and the BP work exemplified how impactful synthesis can be. Just as in a symphony where each instrument contributes a unique sound to create harmony, organic chemical synthesis can come together, can bring diverse elements together to compose solutions that can have a profound impact. It is through this orchestration of individuals, ideas, and efforts that we advance towards new frontiers in medicine and science. To the younger organic chemists, you are entering a field with tremendous potential for impact and innovation. While experimental research can be challenging and sometimes frustrating, persistence is key. Do not be discouraged by setbacks or failures. Instead, use them as opportunities to learn and improve. Keep pushing forward and you will eventually achieve your goals. Dedication and resilience is what matters. On the topic of challenges, my journey to this point has been far from easy. Being an academic is not without its difficulties. If you're interested in hearing more about my experiences, feel free to join me for a coffee. And it's a story that could easily fill another 60-minute lecture. For me, this is just a midpoint. We have many exciting and impactful projects currently underway and in the pipeline. I'm eager to contribute to future breakthroughs. With each project, I aim to deepen my knowledge, expand my skills, and make meaningful contributions to science and society. To the emerging scholars, continue to explore and innovate, conducting your own symphonies of discovery to orchestrate a healthier and more promising future for all. I would like to express my heartfelt gratitude to several key individuals who have significantly contributed to this milestone. This is the incredible team that I mentioned earlier, the shoulders of the leaders on which I stand. Through their guidance, they've shared not just their resources and technical expertise, but also their insight that can't be found in textbooks. With deep gratitude, I acknowledge the profound influence of Profs. Kruger, Maguire, Govender, and Arvidsson on my career. Your vision of mentorship, collaboration, multidisciplinary research, and relevance has not only propelled me to where I am today, but it also instilled in me values that I strive to uphold in my own work. I will forever be thankful for your guidance, support, and opportunities you provided, which have been instrumental in my achievements. At this juncture, I think it's important to recognize that I'm just one of many who this team has nurtured into high positions. To my postdoctoral advisor, Prof. Karl Anker, I'm deeply thankful for your belief in me and your continuous mentorship. To Prof. Isaac, thank you for giving me this job or making the pivotal decision to give me this job. Your unwavering support, advocacy, availability for all my academic needs have been crucial. I am immensely grateful for your efforts. To Prof. Gopal, I am deeply appreciative of your mentorship and collaboration. Your steadfast support, encouragement, and willingness to listen have been a pillar of strength. Prof. Isaac and Gopal have been mentors who have greatly supported me in areas beyond research. Putting this lecture together, I was reminded that success is not achieved in isolation. It is built upon the foundation of a shared vision and collective effort. And I am committed to continuing this vision with the next generation of scholars to achieve their highest potential. I will not be where I am today without the support of my family. To my parents, I am deeply grateful for the values you instilled in me during my upbringing and for the many sacrifices you made on my behalf. I also want to extend my heartfelt thanks to my brother, I hope he's watching, and my sister-in-law for their continuous support, encouragement, and for always cheering on my achievements. The list goes on to express my heartfelt thank you, and as I have not done this alone. The past and present DVCs of the College of Health Sciences, Prof. Slotto and Nkama, thank you for your support and mentorship that have been instrumental in my career advancements. The Dean of Research and the professional staff at CHS, thank you for ensuring we have operational labs. The past and present deans and the professional staff at the School of Health Sciences, thank you for your contributions to seeing to all my teaching and research needs. Thanks to the academic and professional staff at the School of Chemistry, my heart and roots will always be there, especially those that I started with in Howard College. My colleagues at the School of Health Sciences, and in particular the discipline of pharmaceutical sciences, I appreciate your support and collegiality. And at this point, a special thank you to Profs. Vasi Naidu and Shanuka Singh for their mentorship on my teaching portfolio. To the audience members that are here as either my past or present lab mate, colleague, collaborator, student, mentor, or mentee, related to the groups of GGKM, Group 109, and CPRU. Your support and contributions have been fundamental to my progress, and I appreciate you all. Too many names to mention, and you know who you are, and you know the role you've played in my story. Thank you. The various funders, our experimental work and lab infrastructure will not be possible without your generous support. To the suppliers, over the years, we have developed relationships with the handful of suppliers that can support our specific chemical and instrument needs. Our work will not be possible without your vital services. So thank you for the continued partnership. I would like to thank all my friends and colleagues on the various organizations I'm part of for their continuous support. That is OWSD, SciS, AAS, and ASLP. Lastly, I am blessed and thankful to be supported by a host of uncles, aunts, cousins, and loyal friends. Thank you. And finally, I am thankful to those that help me unwind from the demands of academia. And for that, I have to thank my four-legged furry friends and my nieces, Tanika and Paisley. To you all, thank you so much for supporting and listening to me today. Thank you.
Thank you so much, Prof. Tricia Naicker. Thanks so much for presenting your work. We really welcome everything that you've presented. Good afternoon once again. And on the behalf of the College of Health Sciences, it's my distinct honor now to deliver the vote of thanks after such an inspiring and enlightening lecture that has been delivered by Professor Tricia Naicker, which was titled The Symphony of Organic Chemical Synthesis. This afternoon has truly been a testament to the depth of knowledge and passion that Professor Tricia Naicker brings to her field. Firstly, I would like to extend our heartfelt congratulations and gratitude to Professor Naicker for sharing her incredible journey and groundbreaking research with us. Your insights have not only deepened our understanding of organic chemical synthesis, but have also inspired us to appreciate the intricate beauty and complexity of this essential scientific discipline. Your dedication and achievement are a beacon of inspiration for all of us. We also acknowledge and thank every colleague, student, friend, and family member of Professor Naicker for attending today. Your presence and support are invaluable, and it is heartening to see such a strong community gathered to celebrate this momentous occasion. Special thanks are due to the important people who have supported Professor Tricia Naicker throughout her journey. Your encouragement, guidance, and unwavering belief in her potential have been pivotal in her reaching this milestone. We are grateful for your contributions and for being part of her success story. We also express our appreciation to the organizing committee for their meticulous planning and execution of this event. Your efforts have ensured that today's lecture was a resounding success, allowing us to come together in this celebration of academic excellence. Lastly, thank you to everyone who has joined us tonight, this afternoon. Your enthusiasm and engagement have made this inaugural lecture a memorable event. Let us continue to support and celebrate the achievements of our colleagues, fostering a culture of learning and excellence within our institution. Thank you all once again and have a wonderful day. Goodbye.